Let us go to the next question, that if 1 comma z1 and z2 and z3 and so on zn minus 1 are the nth roots of unity, then the value of 1 by 3 minus z1 plus 1 by 3 minus z2 plus and so on plus 1 by 3 minus zn minus 1 is equals to how much? To find out the solution of this problem, let us consider the given data, that 1 comma z1 z2 and z3 and so on zn minus 1, these are all our nth roots of unity. When they are all the nth roots of unity, you can consider the expression z power n minus 1 as all these factors, say z minus 1, z minus z1, z minus z2 and so on z minus zn minus 1. All these are the corresponding factors for corresponding roots 1, z1, z2, z3 and so on zn minus 1. Then from fundamental principle of algebra, the product of the factors is equal to the polynomial. So if I take a logarithm on the both sides, log of z power n minus 1 is equals to log of z minus 1, z minus z1 and z minus z2 and keeping on going, so z minus zn minus 1. This is the expression taken log on both sides. Implies this is the expression where you need to find out this thing. To get that one, let us differentiate on both sides with respect to the variable, that is z. Hence this becomes 1 by z power n minus 1 into derivative of z power n is n into z power n minus 1 minus derivative of 1 is 0, and this is log of z1, z2, z3 becomes here is equals to log of z minus 1 plus log of z minus z1 as keeping on going, so up to log of z minus zn minus 1. If you differentiate this, I'll get 1 by z minus 1 into 1 minus 0 plus 1 by z minus z1 into 1 minus 0 plus 1 by z minus z2 into 1 minus 0. Keeping on going, so last but not the least 1 by z minus zn minus 1 into 1 minus 0. So finally this takes the form of n into z power n minus 1 by z power n minus 1 is equals to 1 by z minus 1 plus 1 by z minus z1 plus 1 by z minus z2 plus and so on 1 by z minus zn minus 1. Further, this can be taken into the numerical form when you substitute for z is equals to 3. That is z is equal to 3 plus 0. When you put z is equal to 3 in the above expression, it becomes n into 3 power n minus 1 by 3 power n minus 1 is equals to 1 by 3 minus 1 plus 1 by 3 minus z1 plus 1 by 3 minus z2 plus 1 by 3 minus z3 plus keeping on going, so 1 by 3 minus z of n minus 1 implies here n into 3 power n minus 1 by 3 power n minus 1 is equals to 1 by 3 minus 1 is 1 by 2 plus 1 by 3 minus z1 plus 1 by 3 minus z2 plus keeping on going, so 1 by 3 minus zn minus 1. So therefore what I require is 1 by 3 minus z1 plus 1 by 3 minus z2 plus and so on plus 1 by 3 minus zn minus 1 is, this half goes that side, leaves you n into 3 power n minus 1 by 3 to the power of n minus 1 minus 1 by 2 as the answer. So which option is going to be the correct here? The correct option is n into 3 power n minus 1 by 3 power n minus 1 minus 1 by 2, that is option B is going to be the correct option for this question. Answer B is the correct option for this question.